Hello and welcome to the Summer Sustainability Summit brought to you by One Click LCA. My name is Muhammad Ali and I am happy to be your host today. The summit is a 2-day free online event for architecture, engineering, construction, manufacturing, and sustainability professionals across the construction value chain. We are delighted to have you here to get inspired, get engaged, and get sustainable. Now let's start this discussion. How are geosynthetics changing the face of sustainable construction in APAC? Featuring Boyd Ramsey, Sam Allen, and we also have Aditi with us. This session is ideal for manufacturers, sustainability consultants, and AEC professionals working in global projects. It will offer a deep dive into sustainable construction practices that are shaping the future of infrastructure in the APAC region. We will also have a live Q&A session at the end, so feel free to drop in your questions in the comments for Sam, Boyd, and Aditi to answer. Before we proceed our session, I would like to say a few words about this event. The Summer Sustainability Summit is brought to you by One Click LCA, the global LCA software empowering the industry to decarbonize and get sustainable. With it, you can comply with more than 80 national regulations, standards, and certifications. You can access the world's largest construction LCA database with more than 250,000 LCA datasets and bring LCA into your existing workflow with more than 20 BIM and other integrations to make your sustainable calculations faster and easier. For over 20 years, One Click LCA has been making the construction value chain sustainable. If you would like to learn more about One Click LCA, you can visit us at oneclicklca.com. Now I would briefly like to present our speakers for the day, starting with Aditi. Aditi Chitnis is a carbon and sustainability specialist within the built environment with extensive knowledge of lifecycle assessments at One Click LCA. Thanks for joining the session, Aditi.
Thank you, Mohammed.
You're welcome. Next we have is Sam Allen, who is the director of TRI Environmental Group, a globally active independent geosynthetic laboratory and research service provider. He is also the current president of the IGS, and his work over the past 35 years has involved significant interaction with public and private entities around the world, giving him a strong understanding of the needs in world regions for geosynthetics, infrastructure, and sustainability. Sam, we are happy to have you here as well.
It's a pleasure to be here with you, Mohammed. Thank you.
You're welcome. And lastly, we have is Boyd Ramsey, who operates as an independent sole proprietor consultancy with global clientele and has worked in the geosynthetic industry for over 3 decades. He has held several council and leadership positions within the IGS, including most recently the former co-chair of the IGS Sustainability Committee. Boyd, we are happy to have you here as well.
Thank you, Mohammed. Happy to be here.
Great. Sam, before we proceed, can you please introduce IGS to our audience and let us know more about it?
Yes, my pleasure. The IGS is the International Geosynthetics Society. We are a learned society with a very strong backbone of academic research lasting for decades. But very special to the IGS is that it's inclusive of many participants in the geosynthetics industry and beyond. We have practitioners, design engineers, contractors, installers, and we also have students at universities that join the IGS. We have over 2,600 members. We are organized into international and national chapters specific to a country or a region, and a very robust organization, all with the mission of letting people know about geosynthetics and specifically how to properly deploy them in successful applications with benefits of economy, performance, and specifically sustainability. This is the IGS. It's very active, and we certainly invite everybody to know about our organization and to join it.
Great. Thank you so much, Sam, for introducing IGS to our audience. All right, let's move forward towards our today's discussion. And to start the discussion, I would like to proceed with the first question, which I would like to ask both of you. Can you please let simply explain our audience what are geosynthetics?
Yeah, I think I can start that response. Geosynthetics are formulated polymeric materials that serve a wide variety of functions. They are very active in civil, environmental, and geotechnical applications. They provide protection for the environment. They provide much lower carbon footprint infrastructure development, both in reinforced soil applications, in drainage applications, in erosion protection, just a wide variety of things that engineering communities work on consistently. These materials, some of them are made of recycled content. Some of them are facilitate more sustainable development. Uh, they're very they're very flexible in their use and very innovative. Innovation with these materials never stops, and a very important material for any engineering student, any engineering any engineering practitioner. So we are very excited to continue to share the story of these materials and educate people about their use.
And we're
Great.
going to talk a lot about sustainability today. Also, an emphasis for geosynthetics is the economic benefit and the scheduling and other benefits. These products you're not buying these to use them because you're trying to save the planet as the only reason. In addition to being something that helps a sustainable behavior and meet the United Nations Sustainable Development Goals, they're also usually less expensive than the other traditional options, and they're usually much easier to build than the other traditional options. So it's a three-pronged success.
It is. Thank you, Boyd. And when we're all university students, Mohammed, we learn in engineering class about performance, right? Design is related to material performance, material properties. Soon after we leave the university and we go to the commercial world, we focus on economy, right? We want the lowest cost solution to almost anything. And now we're moving in the last decade plus, we are more and more aware of the significance of what we're talking about today, sustainability. And geosynthetics just have a monumental benefit here in that space as well. So economy and performance, resilience, sustainability, all these are attributes of the geosynthetic application.
Great. I think that was lovely, and thank you so much for letting our audience know about it. All right, moving on to our next question, which I would like to ask both of you. Can you explain what are some of the innovative applications of geosynthetics in sustainable construction practices? And maybe you can give an example for our audience so it's easier for them to understand.
Sure. Let me get to the example. But first, let me throw in a brief commercial for One Click, because IGS has a relationship with One Click, and it's been a very beneficial relationship, I think, for both parties. I think you got the message from the initial conversation here that geosynthetics are a good thing, but good is relative. Exactly what does good mean? And One Click helps us to quantify the benefits. It's a very important factor that you need to put numbers on it. Many countries now are requiring sustainability and environmental impact analysis with qualifying bids, and this is not this is not writing down on a piece of paper these things are good. It's putting numbers to it, and that's where One Click really comes in and helps. So let me show you an example to maybe help the audience better understand. This is an example, comes to us from Solmax, one of IGS's corporate members, and it's a roadway construction. They're building a roadway to access power grid portions. And a traditional roadway, as you learn in school, you put down a bunch of dirt and soil. You put down some gravel, and that's it. And it's a way to build a road, and that's what a lot of people came out of university are educated for. However, there's a lot better ways to build those roads with geosynthetics. So if you look at those two pictures, particularly the one on the left, what you see is a geosynthetic being deployed in front of the soil roadway. So the geosynthetic can either act as a separator or a separator and a reinforcement. So in this case, instead of deploying, traditionally for heavy construction, you deploy about a half a meter of road thickness. If you use the geosynthetic, you can cut that down to 30 centimeters of road thickness. And that impact is significant and substantial when it comes to transportation, resource usage, et cetera, et cetera. And so it's a very good thing, and it's the most efficient way to build a road. And if everybody came out of university recently, a lot of people would know that. But the benefit that's provided by One Click is the quantification of that. It's one thing for me to tell you that this is good, but using the One Click software and some of the things that we've prepared in there, I can tell you that if you don't use a geosynthetic for 500,000 square meters of roadway, you're going to emit 2.59 million kilograms of CO2. If you use the separator geotextile, you're going to cut that to 2.31 million kilograms of CO2. And if you use a reinforcement geotextile, you're going to cut that to 1.28, or almost half the amount of CO2 emissions that you'd have building it the traditional way. So it's that quantification that One Click offers that really helps us present the benefits of the material.
I think, Boyd, just to add a comment to that, I think the other benefit of One Click is that while you are calculating life cycle analysis, carbon impact of your design, you're invited to think about all those elements of design, right? The raw materials, the transportation costs that are specific to the design. So you're not just able to evaluate the geosynthetic response, but the alternative responses. And that comparison is what articulates, in our experience, the tremendous benefits of geosynthetics. In addition to the lower carbon footprint, we can argue that that's going to be a longer lasting road. The road will perform better than it would have otherwise in terms of resistance to trafficking. So the geosynthetic application to roads is really very important on multiple levels, and certainly sustainability.
And relative to geosynthetics, we're showing you one example here in transportation, but as Sam mentioned earlier, transportation barriers, landfills, walls, infrastructure, all sorts of construction. There's a geosynthetic for almost every infrastructure application.
If I would just chime in here, geosynthetics, basically, you can also quantify them even in the product design stage as well, with the help of either doing product carbon calculations or then even EPDs to actually get the calculations checked, verified, so that when they are used in these applications like infrastructure, roadways, highways, you actually get to see and compare between all your design options and actually use also that quantified version of that product in these applications in order to help benefit for that infrastructure project level as well. And I think that's a massive benefit also of those right now for manufacturers.
Aditi, you're absolutely right. EPDs are the baseline of this. You have the ISO publications on how these calculations are conducted, what information is required. There's independent third-party audits, but the manufacturers have to publish EPDs on the products so that you know what the environmental contribution of that product is. And our industry has done a fair job with that so far. But yeah, the groundswell of EPDs is very important. You need those, and you need the standardization provided by ISO and other organizations so that everybody's doing this the same way. Because this rolls over into the economic considerations as well. And you need standardization. It's a requirement. Now, I'll let Sam speak to that. He knows,
Yeah, well,
he's better at it than
that's
I am.
right. That's right, Boyd. With my IGS hat on firmly, we are very supportive of the EPD push and requirement, and significantly, we're seeing contracting and infrastructure proposals from the contracting community be full of requirements now. For example, in the Netherlands and the UK and other places where the evaluation of these proposals is not just based on economy, it's based on the resulting carbon calculations, the carbon impact of that infrastructure project. So components of that are certainly the EPD and the calculations of carbon. And the IGS is a big participant in with One Click in promoting the numbers, the measurements, as Boyd referenced. So it's data driven. It's very specific drive towards a better world with these much more sustainable projects. So this is a big community. This requires engineers. This requires academics. This requires experts in EPD development and calculations, so that we're all speaking the same language on the way towards a more sustainable infrastructure. So the IGS is a big supporter of this.
Great. I think that was quite insightful. Aditi, would you like to add on something?
No, just to summarize, basically, from both the product side to the application of that particular geosynthetic product into these big projects, every way along the way, the quantification actually matters quite a lot, which is also one of the, as Sam and Boyd said, one of the main economic, that's what you look at right now to help see the benefits of this product. And this is something that has come a long way as well because of this LCA quantification that you can actually do now.
Yes, absolutely. I think that's quite interesting, and our audience might have learned a lot from this example. Thank you so much for answering this question into so much detail. All right, moving on to our next question, which I would like to ask both from all of you, is if you can briefly touch upon what are the environmental benefits associated with using geosynthetics in infrastructure projects.
Right. Well, that's a wonderful question. Certainly, we've just been talking about some of the environmental benefits, right? Anytime we can lower the carbon impact of the use of geosynthetics, we're going to be better for it from a planetary perspective, right? From a global warming perspective. But very specifically in the environmental space, geosynthetics very much had in their very early use some of the initial applications. Some of our geosynthetics called geomembranes have been used for decades to protect the groundwater table. These are components of what we call a composite liner system that provides a very robust barrier between waste, whether that be municipal solid waste or industrial waste, and the water table that we want to keep pristine and clean. Geosynthetics play a key role in every modern containment application that's associated with environmental protection. But they go beyond that because as we move into our future, the preciousness of water resources themselves, where water is hard to come by, reservoirs are being constructed, canals, the infrastructure of water management. All of this requires the modern requirement, the people that are educated about state-of-the-art engineering practice are employing geosynthetics to assist them in their design. Again, you can think of a concrete canal in the Middle East that very soon, with thermal contraction and expansion, will crack. And that crack results in hydraulic infiltration, water loss, infiltration into the ground. Whereas if we put a geomembrane down first and then cover it with concrete, we now have a protective barrier that preserves that water. And many reservoirs are now covering the reservoir with geomembrane type materials that will prevent transevaporation. You think of a large lake or a large reservoir in a very warm region that's increasingly warmer, you worry about evaporation. You worry about the loss of this precious water through transevaporation. And this, of course, retards that by covering that reservoir, keeping the water clean, protecting the water from fugitive soils and wind-blown pollution, and while also preventing evaporation. So there's just lots of geosynthetics in the environmental space. They're used in drainage. They're used to increase the slopes of containment facilities where I might have to build a 4-to-1 or a 3-to-1 slope. With geosynthetic reinforcement, I can increase that to 2-to-1. What does that do? It increases the space in which I can store waste materials or store them pending treatment, things like that. So very, very useful in the environmental space. Geosynthetics are used very broadly in this application.
And just to go back to the canal example that Sam gave, I know a large swath of our audience is Asia Pacific region. Some of the largest projects using these materials are located in this region. The canals in Egypt that Egypt uses to divert a large portion of the Nile and create agriculture and feed all their people. Those are one of the largest installations of geosynthetic materials. And also there are several manufacturers located in the Asia Pacific region. So these products are available there. It's something that's used, just it's used, but it needs to be used everywhere. So.
That's right. That's right. And I would also point out that, included in this environmental space is the preservation of land and prevention of erosion. And geosynthetics are very, very important in these applications, specifically in the Asia Pacific. A lot of coastal erosion is being experienced, loss of wetlands, sea rise, these seawalls and protection of, lots of populations live along the coast, and they're very concerned about land loss and detrimental environmental change in those regions. Geosynthetics are responding with geotube applications, changing the velocity of wave action or river velocity that eats away at the river banks and moves the river in places like Bangladesh and places like Malaysia. These geosynthetics are used in very, very large projects that serve to protect not only the coastal line, but the local communities there, people that are benefiting in their lives from the use of these geosynthetic applications. Very robust use of geosynthetics in environmental applications.
Amazing. I think that was great and quite insightful on how it can be really beneficial into different areas for the different users. Thank you for sharing about the different benefits for our audience, Sam and Boyd. All right, moving on to our next question, which we talked about a lot of benefits, but now we can also talk about the different challenges. So I would like to ask, what challenges do professionals, specifically in the APAC region, face when integrating geosynthetics into construction projects, and how can these challenges be overcome?
And I'm gonna let Sam expand on this, but I'll tee it up for him. It goes to education. We work with the things that we're familiar with and that we're taught about. And a lot of people come out of university and they're taught classes on concrete and sand and gravel and the properties and behavior of those materials. And unfortunately, because geosynthetics are younger than stone, You don't get a class on how to use geosynthetics. And that's something that the IGS is trying to fix. And Sam, if you can describe that for our audience, I think it'd be very beneficial.
Yeah, Boyd, thank you so much. That's exactly right. When I started my term as IGS president, I was in Warsaw, Poland, and I had numerous people remind me immediately what the number one challenge of the geosynthetics industry is, Mohammed. And as Boyd referenced, it's education. And why is that? And Boyd teed it up exactly. Um, the nature of engineering itself is risk management. And many design engineers are risk averse. They define risk as what they don't know, right? If they've done something before and everybody accepted it, they call it safe and reasonable and they want to do it again. And here's a market and a thrust in sustainability and economy and performance that's unfamiliar to them. So, in fact, one of the projects of the IGS right now is educate the educators. What is this? This is the effort to include a 1 hour lecture of geosynthetic knowledge in any engineering undergraduate education. Um, and this is hard in the current education space because engineers have a lot to learn, and the curriculums are stacked, and they're very different depending on if you're going to be an environmental engineer or a geotechnical engineer. And we're after that class that all engineers take, like a materials class or a welcome to engineering class or something like that. The good news is that we have some success. The bad news is that we don't have all success. We're hitting about 65 to 70% of undergraduate classes where the professors are funded by the IGS to attend and educate the educators class, a 1 or 2 day event where they're hand delivered. The curriculum, there's case histories provided to them, there's information about the different types of geosynthetics and their properties and what they're used for. Now, key to this education effort are two additional initiatives that we've started. One is the development of IGS professional development education courses. And these are deep dives. These are 3-day courses that really are focused on increasing your comfort about these applications, how to design with these materials, the importance of proper design, the importance of proper quality. That's one bookend. And on the other bookend, on the other side of Educate the Educators, we've initiated some trial student interest groups or student clubs at universities. We're supporting with regional or local IGS members for lectures and activities. And of course, they have a system of access through a sponsoring professor to get access to the One Click software on these geosynthetic applications. Big benefit from One Click. So IGS is bringing that benefit to we already have student members, but we're inviting them to formally have a charter at a university in the context of an interest group. But it's education. The more people know, the more people use them, and this is going to be a never-ending initiative where we have some regions that are very commonly familiar with geosynthetics. Other regions are not. I can tell you, I was just at the Geo Shanghai conference in Shanghai, China, but the two of the first three keynotes were about geosynthetics. But in a reception on the first night, I was enjoying myself with a number of students, graduate students, and I asked them all whether they knew what a geosynthetic was, and nobody knew. Nobody knew what a geosynthetic was. So I was reminded again that we have a lot of work to do, and certainly our partnership with One Click helps that.
Well, and
Yeah,
sorry, go ahead, Aditi.
Go on, Boyd. No, go on.
This is one of those cases too where people think, oh, America and Europe have all these advantages. Well, with it comes some disadvantages. If you try and change class curriculum for engineering at a university in London or in the United States, it's just the end of the world. You just absolutely can't do it. Whereas, we've conducted Educate the Educator events in Malaysia, for example, and then we've held them in many, many places. And the professor comes and he learns and he goes back, and that semester he includes geosynthetics in his curriculum. So it's something that the Asia Pacific region uptakes a lot faster. They're not quite as regulated, and they're willing to adapt to new ideas faster and easier. So that helps.
No, that's amazing. Like, it's really good that you've mentioned about this trained educators program, because that was actually one of the things that I wanted to ask you. I think just like LCA a couple of years back, we see the same, let's say, analogy right now, where education is the first important step towards understanding basically everything. And I think a few years back, if you look at it, life cycle assessment of anything, even buildings and products, was quite, let's say, only if, it was taken into account, but not so robustly as now you have it, or it's mandated by regulation. And I think this is absolutely a fantastic way of you to, push it ahead and take it ahead across the entire world, really. And it's very good to see that APAC, because of not having that many number of regulations, it's being picked up more and more. What amount of, let's say, manufacturers do you also get expressing this willingness to understand how they can better improve their products? Do you have maybe any insights into that?
Well, one of the frustrating parts of this is that the tools are there. We're making good products that'll do what they need to do. It's not like we're pushing the manufacturer saying, oh, if you made this thing, we'd be able to do this. It's more on the design side saying, we have this thing, this is how you should use it. And again, it's the uptake. We mentioned our regional events. We had a GeoAfrica Congress in Ghana a few years back.
Mm-hmm.
And I will remember this till the end of my career. We had the leadership of the country there. We had their minister for construction. We had their minister for engineering. And these guys stood up and the keynote they gave to the conference and pointed out at the audience and all the engineers saying, you're here to learn the newest, best stuff. We want you to go use it and make our country better. And it was an extremely powerful message, because government plays a strong role in getting engineers to take and it's not a risk, but it's something that they perceive as a risk. Getting the engineer to use something new. Ooh, I don't know about that.
That's right, and I think you point out something really important, which is the policy makers and the decision makers, the policy makers, the protocol developers. They're not always an immediate part of our community, and so our outreach to them is also very, very important. I might mention here that the IGS is a member of 4 geotechnical engineering societies under the umbrella of the federal IGS, FedIGS, and they have joint technical committees, and one of those is on sustainability, led by this gentleman here, my friend Boyd Ramsey. So why would that happen? That happens not because we need another calculator or because we need another educator, but we need position papers. We need papers not coming from the IGS, not coming from the soil ISSMGE or other societies. We need papers representative of the entire engineering community, global engineering community, that tells policymakers it's time to improve, it's time to change and modernize in the context of sustainability. So this is a very important thing that the IGS is a participant in, but in doing everything that we can do. But we need others. We need policymakers. We need decision makers to come join us.
Amazing. I think that's really impactful, and the work you are doing at IGS, and especially the impact it would make in the upcoming generations and in the upcoming world, that would be huge. So thank you so much for your efforts and for answering this question. We can now move towards our last question for the day, for the discussion. And for that, I think we can briefly talk about basically what are the emerging trends in the use of geosynthetics for sustainable development, since it's kind of a new thing and it's still developing. So there are a lot of different emerging trends all around the world. So we can maybe discuss about it, how they are differing, and what are the upcoming trends you see that would be there in the future.
Yeah, let me start that, and I'll let Boyd chime in as well. This is the exciting space. Of course, there's a lot of innovation in geosynthetic product development and application. But one of the more intriguing aspects of geosynthetics is the invitation through their use to use soils and other geomaterials that have traditionally been avoided. For example, recycled coal ash or expansive soils, or soils that you wouldn't, that would be a automatic geotechnical challenge to work with. The geosynthetic solution also invites their use, because the geosynthetics can provide the needed drainage or the needed containment or the needed performance in lieu of a better performing aggregate. We've already talked about the savings of aggregate. Aggregates in general, sands and gravels, they're fundamental for decades, ever since the beginning of road building in early times, centuries ago, right? We used preferential soils to build infrastructure. That's never going to end. But what happens is, when we use geosynthetics, we can use less of them, and we can make the geomaterials that we do use last much longer in their application. So these are, again, sustainable, sort of flavored contributions of geosynthetics to these applications. The use of materials that are right there at the job site, rather than trucking in 1,000 trucks of a competent aggregate. Let's use what we have with the use of geosynthetics, and also let's use less of a road aggregate via the inclusion of a geogrid, a separator fabric, that kind of engineered road using geosynthetics. I'll also tell you that in the hydraulic space, there's the innovative new products. I was in a meeting yesterday looking at the standardization guide for what's called the geosynthetic cementitious concrete materials. These are blankets of concrete housed between two geotextiles. Why would we use those? Because they're ready-made canal materials. They're ready-made barriers that prevent infiltration. They're flexible. You move them out in the field, you hydrate them, and they set. And this is very nice for severe, especially right after emergency superstorm events, flooding, fire, where the post-fire ground is very susceptible to a high degree of erosion. These erosion materials, these canal materials, are a big part of this hydraulic management. So a lot of innovation in the geosynthetic space and within our industry.
Amazing. Thank you so much for answering. Yes, Boyd.
Yeah, just a couple words on a different take
Yeah.
on this. For the younger folks out there, because I'm an old man. One of the trends here is speed. The uptake of sustainability has happened faster than any other trend I have seen in my entire career. And my comment to that is thank God, because it needs to. But Aditi, you mentioned the evolution of One Click LCA, going from education and the good, the online tutoring you guys provide, and now people are moving into using. And that same thing is happening with sustainability contributions to geosynthetics. It's, people talked about them a little bit a couple years ago, and now we've got standards and numbers and practices and programs like One Click LCA to put a figure to it that you can take to an owner who's concerned about economics, a regulator who's concerned about CO2 emissions, and say, look, these are the numbers of the choices you're going to make here.
Yeah, thank you so much for letting us know about that, Boyd. I think that was really quite insightful, and the discussion was, I hope everyone has a lot to learn from that. So thank you so much for answering that. Now to wrap this up, I think I would like to present our top 3 takeaways for our today's discussion for our audience. So Sam and Boyd, if you can please read them out loud for our audience.
Sure. To emphasize what I just said again, the quantification of these benefits. These products are good. They work well. They allow you to do things that you couldn't do otherwise with materials that you probably couldn't use otherwise. But you have to put numbers to that. You have to connect it to the economics. You have to connect it to a more sustainable product, less CO2 emissions, more water conservation, less electricity usage, and the use of the EPDs and the One Click LCA software allow you to quantify all that, and it's critical.
Great.
Yeah, amen to that, Boyd. And prioritizing. What does prioritizing mean? It's really very important that as a community of engineers, as a community of academics, of participants in this push, that we really very much communicate with the decision makers that help us prioritize this. It's very hard to get out and promote a sustainability project when the only consideration is economy, or the only consideration is something unrelated. So sustainability goes with everything, and we need to spread the word of sustainability. Teach, as Aditi said, education, and we also need to hold hands with regulators so that they understand that this is the future. This is what we all have to do for the sake of the planet, for the sake of modern, practical, state-of-the-art engineering. This is very important. And then finally, number 3, especially I'll speak to the young people too. This has to be a part of the future, and you're the ones that will lead it, right? This must be a part of every infrastructure bid, every design process. The tools that you need are how, like One Click and like recycled materials, like high performance sustainable materials. These are the materials that you will build with. And I will tell you that some of the traditional materials are less and less available. So the geosynthetic response, the recycled pavement response, the solar powered light response, the smart roads, the sponge cities that accept water, all of this is a part of a sustainable infrastructure future that must be realized. It's very important for our governments, for our population, for our planet, for our environment, all the above. And quite honestly, you're in the right place at the right time. You are there. You're attending this seminar on sustainability. You're doing it exactly right. And Godspeed. This best of luck to you. I will tell you from my career, use all the resources you can. Certainly the IGS is one of many very good resources, but IGS is a very important one. So please join us. Please be aware of our work and come join us at the International Geosynthetics Society. Thank you.
Amazing.
Those are the take-homes.
Amazing. Thank you so much for sharing these interesting takeaways with our audience. Now, before we get started with our live Q&A, which we all have been waiting for, I would love to let you know more about IGS and One Click LCA. IGS also offers corporate memberships with tons of benefits to its members, such as access to IGS's membership directory, digital library and newsletter, discounted rates for IGS publications, conferences, and events organized by the IGS. You also get eligibility to be granted an IGS award And you can also access various other workshops, trainings, and educational programs like the one which Sam and Boyd just mentioned, Educate the Educators program. If you would like to learn more about the memberships and IGS, you can visit geosyntheticssociety.org, which you can find the link in the comments. And moving on, I would also love to let you know more about One Click LCA's APD software platform. With the APD generator, you can quickly and easily automate your APD generation process. And in order to demonstrate your environmental impact, in order to get your products specified and purchased for your construction projects. In case you would like to book a demo and get advice on decarbonizing your products, just click yes on the poll that you can see now on your screen, and our business team of XPD experts would be happy to consult with you and help you understand how to differentiate your products and win more business with APDs efficiently. So please feel free to answer the poll and we will reach out to you. And finally, the moment we all have been waiting for, let's move towards our live question answer from the audience. So the first question we have is, can geosynthetics be used in all climates and environments, and what specific factors should drive the application of geosynthetics in projects? Would you like to answer that, please?
Sure, I'll go.
Okay.
The answer to climates and environments is yes, all of them. We've done work in the poles, in Antarctica and Arctic environments, where geosynthetics are acting as barriers to protect the fragile ecosystem from human existence there. And we work, as we've mentioned during the discussion, right along the equator, where it's hotter than Hades, as it's been in India lately, where you can use these materials, actively. And in terms of specific factors, there's a multitude of factors to do that, but we provide case histories and instruction on how to go forward. Sam, go ahead.
Yeah, I would say from an engineering perspective, Boyd, these polymeric materials are temperature sensitive, and that's fine. We can design with that. In fact, it's even beneficial in some design cases. We design with the fact, like for example, in reinforced soil, that at a higher temperature there may be more flexibility. So we build that into a reinforced soil application. So the geosynthetics are amazing in their resiliency and their flexibility of design and use. And this is one of the benefits of geosynthetic use. And again, education. If we can teach people about the design, about the resources available to learn design and practice, then we're all the better for it, and there's more comfort in using them.
Great. Thank you so much for answering. We have another question from the audience, which I'd like to ask from you. And that is, how is the design of geosynthetics optimized for sustainability in various civil engineering and applications? So, Boyd, Sam, can you briefly answer that?
Yeah, I'll take this one. Certainly, the big optimization by the use of geosynthetics in most applications is the avoidance of carbon-heavy footprint aggregate use or soil use. That's an immediate benefit. So, how is the design optimized? If we can include geosynthetics in almost any design, we are consequently saving the carbon footprint. We're lowering the carbon footprint. And this isn't 5%, 10%. Most of these applications, as demonstrated through measured one-click calculations, is in the range of 25, 30, all the way up to 85, 80% carbon savings. So very dramatic benefits through the use of geosynthetics.
Maybe one more thing if I add there. Sorry, Boyd.
No, go ahead.
Just one more thing if I add there, like for geosynthetics, it's also so straightforward and a faster way of installation, compared to all the traditional materials that you said, like imported fill, aggregates, whatnot. And then plus on top of that, you can also use these as a way for, when you use them, you have alternate transportation, and you also have different, an optimal construction method that you use that in a way affects the carbon altogether. Like it's
Well,
a
not in a
holistic.
way, Hadid. Exactly,
Exactly.
exactly.
It does.
Um,
Yes.
you know, we have a couple slides that we use. One container of geosynthetics generally replaces around 100 truckloads of whatever it is you're hauling, sand, gravel, et cetera, et cetera. So, and that impact hits, scheduling, it hits road wear, it hits all sorts of applications positively. But you're absolutely right. It's that lack of running those trucks all over the place, much less carbon emissions.
Great. Thank you so much for answering the questions, Sam and Boyd and Aditi. Like as we talked about the education, so I would love to let you know more about One Click LCS free sustainability programs. They are part of our commitment to train 1 million low carbon experts by 2030. So you can also access hundreds of hours of on-demand course materials at One Click LCA Academy and attend our live weekend-long bootcamp for a comprehensive training on EPDA and LCA concepts with our experts. So you can scan this QR code or visit the link in the chat to learn more about this. And moving on, I would also love to let you know more about the One Click LCA Low Carbon Manufacturing Awards 2024. It is meant to celebrate sustainable practices and low carbon manufacturing solutions in manufacturing. So it is open to manufacturers of all sizes across all industries. And this contest is your opportunity to gain global visibility through extensive media exposure, benchmark your product against peers and competitors, and win more business. So please do check out by scanning the QR code or visit the link in the comments. Next up in the summit, you can join Trimble to learn more about optimizing APD creation and streamlining LCA workflow, and we will see you there in a few minutes. Finally, to wrap it up, we are always happy to hear from you. If you would like to reach out to us, please visit oneclicklca.com, and you are also welcome to follow us on our LinkedIn and YouTube channels. I would like to thank everyone who joined today's session and would especially like to thank our guest speakers, Aditi, Sam, and Boyd. It was a pleasure having all of you in this session.
Thank you both.
Mohammed.
And
You're
thank to
welcome.
the
Thank you,
audience.
Sam and Boyd. It has
Yeah.
been super insightful with
Yeah.
all the case studies. Thank you.
Absolutely. I hope this session was really insightful for everyone. Have a lovely day. That's all for now, and see you next time.